Welcome my dear student in our math program for secondary 3. Dear student, today we are taking new lesson in static. What is the title? Title Parallel Forces or Resultant of Parallel Forces. Dear student, we have two types of two parallel forces in same direction and opposite direction. Dear student, look at introduction of resultant of two parallel forces. Look at the figure. We have two forces F1, F2. F1 acts at point A, F2 acts at point B, are resultant of two like forces. Like forces means two parallel forces as F1 and F2. Resultant of two like forces or parallel forces have the same direction. R is a force in the same direction of the two forces. Resultant of two like forces F1 and F2 is R in the same direction of the two forces. Its magnitude is equal to sum of magnitude of the two forces, and direction is sum or direction is same of the two parallel forces. We have F1 and F2, two forces. The first acts at point A, the second acts at point B. Then resultant of the two parallel forces equals sum of two forces F1 plus F2, and its direction in the same direction of F1 and F2. Then vector R or resultant of the two forces equals sum of two forces or equals F1 plus F2. Dear student, line of action divides the distance between two lines of the action of two forces. Look at R, resultant of the two forces at a point C. C divided AB as a ratio, AC to BC. Then an inverse ratio to their magnitudes. F1 times AC equals F2 times BC. Dear student, this equation is very important. When we find R is magnitude of F1 plus F2, what is the direction of R? We use F1 times AC equals F2 times BC. By other methods, we form F1 over F2 equals what? Yes, AC over BC. Example. Two like forces of magnitude 5 and 7 newtons act at the 2 points A and B, where AB equals 36 centimeter. Find the resultant of the two forces. Look at the solution. Dear student, we have distance between A and B 36 centimeter. The force F1 equal 5 act at point A. 7 force 2 act at point B. What is the resultant of the two forces? Look at the figure. Let's see B unit vector in the direction of the two forces. F1 equal 5C, F2 equal 7C. What is R? The resultant of the two forces equals sum of two forces F1 plus F2 equals 5C plus 7C, same direction, equal 12C. Identify the point of action of the resultant. Look at dear student. C is the point of action of R. Then let's see belongs AB line segment. Therefore, AC over CB equal 7 over 5. Therefore, AC over 36 minus AC. AB equals 36. AC, we divided AB into two line segment or two lengths. AC and 36 minus AC. Then AC over 36 minus AC equals 7 over 5. By using cross multiplication, 5AC equals 252 minus 7C. Therefore, AC equals 21 centimeter. What you mean AC equal 21 centimeter? Means R, or resultant of the two forces 5 and 7 at 21 centimeter from the point A. The magnitude of the force of resultant is equal to 12 newtons. It acts in the same direction of the two forces, and it acts at a point which is 21 centimeter distant from point A. Now we are translate resultant of two unlike forces. What do you mean of unlike forces? Unlike forces means opposite forces. F1 opposite direction of F2. Look at, dear student, we have two forces, F1 and F2. F1 acts at point A, F2 acts at point B. When we find the magnitude of the R, let's see, belongs to BA line segment, doesn't belong AB line segment, BA array. C belongs to B array, doesn't belong BA line segment. R in this case equals F1 minus F2. Let F1, F2 are two parallel unlike forces. What do you mean of unequal forces? Unequal, don't equal. F1 not equal F2. F1 and F2 in the opposite direction act at 2 points A and B in rigid body, and their resultant is R. In this case, R equal F1, F2, but F1 is more than F2, or R is the same direction of the greatest force F1. F1 is positive, F2 is negative, and act as a point C, which divides AB externally. C divided BA externally as a ratio BC and CA. Remember, dear student, we have two forces, F1, F2, opposite direction. F1 acts at point A, F2 acts at point B. Then R acts at point C, which C divides BA externally as a ratio BC and CA. C or R acts in C in an inverse ratio of the magnitude inverse ratio of the two forces. F1 more than F2, then AC over BC equals what? Yes, F2 over F1 by using cross multiplication. Then F1 times AC equals F2 times BC. Note that, dear student, the resultant of the two unequal and unlike forces is a force in the direction of the force of the greater magnitude. Its magnitude and its line action divided the distance between the two lines of action of the two forces externally. From the slide of the forces of the greater magnitude in as inverse ratio to their magnitude. Example: two unlike forces, magnitude 40 and 100 Newton, and the distance between the two lines of action is 240 centimeter. Find their resultant. Dear student, look at, we have two forces, 40, 100 Newton. AB, distance between them, AB equal to 140. The greater is 100 Newton, the smallest is 40 Newton. R in this case in same of the greater force, 100. Look at R acts at point C externally from AB. Then C divided BA externally as ratio, yes, CA and CB. Remember, dear student, look at C unit vector in direction of the greater force. The unit vector C in the direction of the greater force, and direction of resultant force. F1 in this case equals 100c, F2 equals 40 or negative 40 in the opposite direction, negative 40c. After that, we have resultant of the two forces, sum of the two forces. R vector equal F1 plus F2 vector equal 100c minus 40c equal 60c. R is 60c. In this case, dear student, R equals F1 plus F2, but F2 in the opposite direction must be equal negative 40. Then R equals 100c minus 40c equal 60c. Therefore, CA over CB equals what? 40 over 100. The ratio between CA and CB equals F2 over F1 by CA substitution about CB equals, look at CB. CB in the graph equals AB plus AC. AB equals 240 plus CA or AC. Then CA over 240 plus CA equals what? 2 over 5. What do you mean over 2 5? Simplest form from 40 over 100. Then the equation becomes CA over 240 plus CA equal 2 over 5 by using cross multiplication. AC equals 160 centimeter. What do you mean? AC 160 centimeter. R or resultant of the two forces, act at 160 centimeter from A, or yes, 400 centimeter from point B. Dear student, we have magnitude of R. Resultant of the two forces equal 60 Newton. This 60 Newton is act at point C. Where is the C? C is far from A, 160 centimeter, or 400 from point B. This example is very important. We have two forces. Two forces unlike. What is the meaning of unlike two forces? Unlike is opposite direction. F1 more than F2. Then R equals sum of two resultant. R is sum of the two forces. F1 plus F2. F1 100, F2 40. We find 100 minus 40 in C unit vector. Then the resultant of the forces is 60 Newton. After that, we find the action of the resultant by using inverse ratio. Dear student, look at another example. Magnitude of the resultant is equal 60 newtons. Its direction is the same direction of the two forces, 100 Newton. Remember, dear student, magnitude of resultant, what is R? Is magnitude 60 Newton. This 60 Newton, its direction has direction in the same the direction of the force of 100 Newton. It acts at the point belongs to B ray and doesn't belong AB line segment, and it's 160 centimeter from part from A. Dear student, now we are translate to theorem. What is the theorem? Sum of moment of finite number of parallel coplanar forces about any point in its plane is equal to moment of resultant of these forces about the same point. Look at important example. Two parallel forces of magnitude 20 and F Newton act at 2 points A and B. The magnitude of the resultant is 35 newtons and the distance between the lines of action of known force and the resultant is equal to 15 centimeter. Find F in each of the following two cases. The first, the known force and the resultant are in same direction. Number B, the known force and resultant are in the opposite direction. Look at the solution. Look at F1, F2 in the same direction, R act at point C such as AC equal 15 centimeter. Let's see unit vector in the direction of the resultant. R equal 35 C given F1 equals 20 C. When we find the value of unknown, then R equals F1 plus F2. By substitution is 20 C plus F2. F2 equals 15 centimeter. 15 C. Why? Because R equals 35. R equals 35. R equals F1 plus F2. F1 equals 20. Then F2 equals 15 C vector. The sum of moment about C is equal to moment of the resultant about C equals 0. This is 0. Sum of moment about C is equal to moment of resultant of point C equals 0. Look at, we have moment of C, then 20 times 15, negative 15 times BC equals 0. Therefore, dear student, we find the BC equals 20. Why? Because 20 times 15 equals 15 times BC divided by 15. Therefore, BC equals 20 centimeter. The force F2 acts at point at distance of 35 centimeter from A. Remember, the force F2 acts at a point distant at a distance 35 centimeter from point A. Look at F1, F2, AB, then F2 act at point A, F1 act at point B, R act at point C. Let's see B unit vector in direction of the resultant. We have unlike forces, F1, F2 unlike forces. Therefore, R equals 35C, F1 equals negative 20C. Therefore, R equals F1 plus F2. Then 35C equals negative 20C plus F2. We find the value of F2 equals 55C. Look at the student. In this case, F1 in opposite direction F2. AC equal 15 centimeter. When we find R equal F1 plus F2, to find the value of F2, then F2 equals 55C. After that, by using the theorem of moment, then 20 times 15 equals negative 55 times BC equal 0. We find the moment about point C. Then F1 equals 20 times 15 distant AC. Negative 55 is the value of magnitude of F2 times BC equals 0. After that, we find the value of BC. Therefore, BC equals 60 over 11 centimeter. What do you mean? Means the F2 act as 60 over 11 from point C. Force F2 acts at point B as a distance 105 over 11 centimeter from E. Now we are to translate two important examples. Two parallel forces of magnitude 20 and F Newton act at the 2 points A and B. The magnitude of the resultant is 35 newtons and the distance between the line of action of known force, and the resultant is equal to 15 centimeter. Find F in each of the two following cases. The first, the known force and resultant are in the same direction. Number B, the known force and the resultant are in the opposite direction. Solution. Dear student, look at, let's see B unit vector in the direction of the resultant. R equals 35C, F1 equal 20C, then R direction equal F1 plus F2. Resultant of the two forces, sum of the two forces. What is the 20C plus 50 F2? What is R? 35. Then F2 equal 15 over, or F2 equals what? 35 minus 20 equal 15C. Remember, R in this case, dear student, equals 35. And F1 equals 20. Must be F2 equals 15. Why? Because R equals F1 plus F2. R 35, F1 20. Then F2 35 minus 20 equals 15C. The sum of moment about C is equal to moment of the resultant about C equal to 0. To find BC by using 20 times 15 minus 15 times BC equals 0. Therefore, BC equals 20 centimeter. What you mean? The force F2 acts at point at the distance of 35 from A. Look at the second F1, F2 in the opposite direction. Remember, BC equals 15. And C is the unit vector in the direction of the resultant. Remember, R is the direction of R is the direction of the greatest force. Then R35C, F1 negative 20C. Therefore, F2 by using R equals F1 plus F2. Substitution about R equals 35C, F1 negative 20C. F2, find the value of F2 equals 55C. After that, we use the theorem of moment. 20 times 15, 20 what is F1 magnitude F1 times distance 15 negative 55 times BC equals 0. To find the value of BC, BC equals 60 over 11. Then C, BC equals 60 over 11 means R, yes, or F2 at a distance 60 over 11 centimeter from C, or 15 minus 60 over 11 from A. Then force F2 at the point B at the distance 105 over 11 centimeter from A. Dear student, now we are translate to important example. F1 and F2 are two parallel forces acting at the point A and B. F1 its magnitude 40 Newton, F2 70 Newton, distance AB equal 50 centimeter. Find the resultant of F1 and F2 if two cases. The first, they have same direction. Second, they have two opposite direction. Solution. Look at, dear student, we have two forces, F1 and F2. F1 equal 40, F2 equal 70. The two forces are acting at the same direction. Then R is sum of the two forces and in the same direction. Dear student, AB equal 50 centimeter. Let's see, belongs to AB and AC equal X. Then CB equal 50 minus X. F1 and F2 resulted of F1 and F2 in the same direction equal 70 plus 40 equals 110 Newton. Moment of 40 times X equals what? Or 50 times x minus 70 times 50 minus x equals 0. We obtain the equation. Left hand side 4 times x, right hand side 70 times bracket contains 50 minus x divided by 10. Then 4x equals 350 minus 7x. Look at the student. We find 11x equals 350. Find the value of x. Divided 350 by 11. Then the value of x from the point A. C belongs to AB line segment. Then AC equal 350 over 11 centimeter. Look at the second case, F1 and F2 in the opposite direction. F1 40, F2 70, distance between them equal 50 centimeter. R is the resultant of the two forces, each direction in the greater force, 70. Let's see R, C, point C, R acting on the point C, BC x, then AC equal 50 plus x. What is the value of R? R F2 minus F1 equals, yes, F2 70, F2 40, then R equal 30 Newton. By using the theorem of the moment, 40 times 50 plus x, moment about C, equals what? 70 times x. By using divided by 10, therefore 200 plus 4x equals 7x. What is the value of x? Then 3x 200, 3x over equal 200, or 200 equal 3x divided by 3, x equal 200 over 3 centimeter. The resultant act at 203 centimeter from the end B. Look at, if we have two forces 40 and 70 in the opposite direction, R resultant of the two forces equal 70 minus 40 equal 30. This value of R 30 Newton act at 200 over 3 centimeter from the end B. Another example. The magnitudes of the two parallel forces are 30 and 70 Newton. They act as the 2 points A and B. AB equal 200 centimeter. Find the resultant of the two forces and the distance between its action point and the point A is given that the two forces, number one, have the same direction, number two, have the two opposite direction. Solution. Look at, dear student, we have two forces F1 30, F2 equal 70, distance AB equal 200. Let's see belongs to AB, such as BC equal x, AC equal 200 minus x. Remark, dear student, R act at point C. C belongs to AB line segment. What is the value of R? Value of R equals sum of the two forces, F1 plus F2 equal 30 plus 70 equal 100 Newton. After that, this is magnitude of the resultant. After that, we find action of the resultant of the two forces by using moment of point C. F1 times AC equal F2 times x. Look at, dear student, AC equal 200 minus x. By substitution, F1 equal 30 times 200 minus x equals F2 70 times x. Divided by 10, then 3 times 200, 600, 3 times x, 3x, 7 times x equals 7x in right hand side. By using right hand side and left hand side, 10x equals 600 or 600 equal 10x, therefore x equal 60 centimeter. Then R, its magnitude is 100 and act at point C at 60 centimeter from point B, or 140 from point A. Then AC equals 140 centimeter. Therefore, the point of action of resultant is at 140 centimeter from point A. Dear student, we have two forces. The first is 30, second is 70. In the same direction, we find the resultant of the two forces by adding 30 plus 70 equal 100. After that, by using theorem of moment, we find moment at point C. Then F1 times 200 minus x equal F2 times x. By substitution about F1 equals 30, F2 equals 70. Therefore, we find the value of x equal 60. Therefore, AC equal 100. Then the point of action of the resultant is at 140 centimeter from point A. Dear student, I am very happy to spend such time with you. Remember, math simple, think, work, produce. Goodbye.